Here we have a circuit. We are going to use the superposition method to calculate the current and the power dissipated in this resistor R2. Let's call it I2. Okay, let's call it I2. And here we call it I1 and I3. So we can divide this circuit because there are two sources, so it means we will have two circuits. First circuit, we replace one of the sources by a short circuit, and we use one of the sources. For example, let's start with the first one. Here is the first circuit. We have R1, V1, R2 and R3, and the source V2 is replaced by a short circuit. Let's call this current I2 prime, this is I1 prime, and this is I3 prime. Here is the source voltage V1 in volts, 56, 60 degrees, and the second circuit is second source. We replace V1 by short circuit, and we have R1, R2, R3, and V2, which is equal to 90 minus 30 degrees. And this current is called I2 2 prime, I3 2 prime, and I1 2 prime. Okay, let's start with this circuit and try to calculate I2 prime. Okay, as I said, we are going to use the current divider. It means that if you remember, I will quickly give you the equation for current divider. If you have two resistors in parallel, if we have I1 here and I2 here, we can calculate I1 and I2 in function of the main current, and I will give you a formula times I, and here is R1 over R1 plus R2 times I. That's what we're going to use. First of all, we have to calculate, of course, the equivalent resistance of this circuit. So it means the equivalent resistance is R1 plus R2 in parallel with R3. And here R1 is 15 plus 30 times 20 over 50, and this is 12, so it means 27 ohms. From this we can calculate I1 prime is equal to V1 over, this is Z, or it's resistance, not impedances. Okay, V1 over RE, and this is equal to 56, 60 degrees over 27, and the result is 2.074 and argument 60 degrees. We calculated I1 prime, we need I2 prime. I2 prime is equal to, in function of it's R3 over R2 plus R3 times this current, and R3 is equal to 20 over R2, 30 plus 20 times 2.074 60 degrees. So this current is 0.83 and argument 60 degrees. So we write it here. It's 0.83 60 degrees. Okay, now we go back to the second circuit, which is here. I take another bolt, and here same thing. We calculate the equivalent resistance, which is equal to R3 plus R1 in parallel with R2. So it means R3, which is 20 plus R1, R2, 15 times 30 over 45, and the equivalent resistance is 30 ohms. From this we can calculate I3 2 prime, which is equal to V2 over RE. V2 is 90 minus 30 degrees over this 30 will give us 3 amps and minus 30 degrees. From this we can calculate I2 2 prime, which is equal to R1 over R1 plus R2 times I3 2 prime. So R1 is 15 over 15 45 times 3 minus 30, which will give us a value of 1 minus 30. Here we have 1 minus 30 degrees. So now we can do the sum of the two currents. So I2 is equal to I2 prime plus I2 second, which is equal to 0.83 60 degrees plus 1 minus 30 degrees, and this is equal to 0.4148 plus j times sine 60, and this is j point, excuse me, we have to use point 7184 plus 0.866 minus j. Sine of 30 is half minus half. This will give us current of 1.281 plus j 0.2184. In polar form is 1.3 and 9.675 degrees, and we can calculate the power dissipated in that resistor. It's R2 times I2 squared, and this is R2 is 30 times 1.3 squared, and this will give us a dissipated power of 50.7 watts. And that's it, and thank you very much.